Welcome to CO556 Network Systems. This is week 7 and this is chapter 10 of the Cisco syllabus, and this week we're looking at LAN security concepts. So the objective this week is to explain how vulnerabilities compromise LAN security. We'll explain how to use endpoint security to mitigate attacks. Explain how AAA and 8021X are used to authenticate LAN endpoints and devices, to identify layer 2 vulnerabilities, and explain how a MAC address table attack compromise LAN security, and explain how LAN attacks compromise LAN security. So endpoint security. So network attacks today. The news media commonly covers attacks on enterprise networks. Simply search the internet for latest network attacks to find up-to-date information on current attacks. Most likely, these attacks will involve one or more of the following: distributed denial of service, DDoS. This is a coordinated attack from many devices called zombies, with the intention of degrading or halting public access to an organization's website and resources. A data breach. This is an attack in which an organization's data servers or hosts are compromised to steal confidential information. Malware. This is an attack in which an organization's hosts are infected with malicious software that causes a variety of problems. For example, ransomware such as WannaCry encrypts the data on a host and locks access to it until a ransom is paid. Network security devices. Various network security devices are required to protect the network perimeter from outside access. These devices could include the following: Virtual Private Network, VPN, enabled router. Provides a secure connection to remote users across a public network and into the enterprise network. VPN services can be integrated into the firewall. Next Generation Firewall, NGFW. Provides stateful packet inspection, application visibility and control, a Next Generation Intrusion Prevention System, NGIPS, advanced malware protection, AMP, and URL filtering. Network Access Control, NAC. Includes authentication, authorization, and accounting, or AAA services. In larger enterprises, these services might be incorporated into an appliance that can manage access policies across a wide variety of users and device types. The Cisco Entity Service Engine, ISE, is an example of a NAC device. Endpoint protection. Endpoints are hosts which commonly consist of laptops, desktops, servers, and IP phones, as well as employee-owned devices. Endpoints are particularly susceptible to malware-related attacks that originate through email or web browsing. Endpoints have typically used traditional host-based security features such as antivirus and anti-malware, host-based firewalls, and host-based intrusion prevention systems, HIPSs. Endpoints today are best protected by a combination of NAC, Network Access Control, and AMP software, an email security appliance, ESA, and a web security appliance, WSA. Cisco Email Security Appliance. The Cisco ESA device is designed to monitor Simple Mail Transfer Protocol, SMTP. The Cisco ESA is consistently updated by real-time feeds from the Cisco Talos, which detects and correlates threats and solutions by using a worldwide database monitoring system. This threat intelligence data is pulled by the Cisco ESA every 3 to 5 minutes. These are some of the functions of the Cisco ESA. It blocks known threats, remediate against stealth malware that invade initial detection, discard emails with bad links, block access to newly infected sites, and encrypt content in outgoing mail to prevent data loss. Cisco Web Security Appliance. The Cisco Web Security Appliance, WSA, is a mitigation technology for web-based threats. It helps organizations address the challenges of securing and controlling web traffic. The Cisco WSA combines advanced malware protection, application visibility and control, acceptable use policy controls, and reporting. Cisco WSA provides complete control over how users access the internet. Certain features and applications such as chat, messaging, video and audio can be allowed, restricted with time and bandwidth limits, or blocked according to the organization's requirements. The WSA can perform blacklisting of URLs, URL filtering, malware scanning, URL categorization, web application filtering, and encryption and decryption of web traffic. Access control. Authentication with a local password. Many types of authentication can be performed on networking devices, and each method offers varying levels of security. The simplest method of remote access authentication is to configure a login and password combination on console, VTY lines, and auxiliary ports. SSH is a more secure form of remote access. It requires a username and a password. The username and the password can be authenticated locally. The local database method has some limitations. User accounts must be configured locally on each device, which is not very scalable. The method provides no fallback authentication method. AAA components. AAA stands for Authentication, Authorization, and Accounting, and provides the primary framework to set up access control on a network device. AAA is a way to control who is permitted to access a network, authenticate, what they can do while they are there, authorize, and to audit what actions they performed while accessing the network. That's the accounting. Authentication. Local and server-based are two common methods for implementing AAA authentication. Local AAA authentication method stores usernames and passwords locally in a network device, e.g. a Cisco router. Users authenticate against the local database. Local AAA is ideal for small networks. Server-based AAA authentication. With the server-based method, the router accesses a central AAA server. The AAA server contains the usernames and passwords for all users. The router uses either the remote authentication dial-in user service, RADIUS, or terminal access controller access control system, TACACS, protocols to communicate with the AAA server. When there are multiple routers and switches, server-based AAA is more appropriate. Authorization. AAA authorization is automatic and does not require users to perform additional steps after authentication. Authorization governs what users can and cannot do on the network after they are authenticated. Authorization uses a set of attributes that describes the user's access to the network. These attributes are used by the AAA server to determine privileges and restrictions for that user. Accounting. AAA accounting collects and reports usage data. This data can be used for such purposes as auditing or billing. The collected data might include the start and stop connection times, executed commands, number of packets, and number of bytes. A primary use of accounting is to combine it with AAA authentication. The AAA server keeps a detailed log of exactly what the authenticated user does on the device, as shown in the next figure. This includes all exec and configuration commands issued by the user. The log contains numerous data fields, including the username, the date and time, and the actual command that was entered by the user. This information is useful when troubleshooting devices. It also provides evidence for when individuals perform malicious acts. 8021X. The IEEE 802.1x standard is a port-based access control and authentication protocol. This protocol restricts unauthorized workstations from connecting to a LAN through publicly accessible switch ports. The authentication server authenticates each workstation that is connected to a switch port before making available any services offered by the switch or the LAN. With 802.1x port-based authentication, the devices in the network have specific roles. The client, or supplicant, this is the device running 802.1x compliant client software, which is available for wired or wireless devices. The switch, the authenticator. The switch acts as an intermediary between the client and the authentication server. It requests identifying information from the client, verifies that the information with the authentication server, and relays a response to the client. Another device that could act as authenticator is a wireless access point. Authentication server. The server validates the identity of the client and notifies the switch or wireless access point that the client is or is not authorized to access the LAN and switch services. Layer 2 security threats. Layer 2 vulnerabilities. Recall that the OSI reference model is divided into 7 layers, which work independently of each other. The figure here shows the function of each layer and the core elements that can be exploited. Network administrators routinely implement security solutions to protect the elements in layer 3 up through layer 7. They use VPNs, firewalls, and intruder protection systems, devices to protect these elements. However, if layer 2 is compromised, then all the layers above it are also affected. For example, if a threat actor with access to the internal network captured layer 2 frames, then all the security implemented on the layers above would be useless. The threat actor could cause a lot of damage on the layer 2 LAN networking infrastructure. Switch attack categories. Security is only as strong as the weakest link in the system. The layer 2 is considered to be that weak link. This is because LANs were traditionally under the administrative control of a single organization. We inherently trusted all persons and devices connected to our LAN. Today, with bring your own device and more sophisticated attacks, our LANs have become more vulnerable to penetration. Here we see a number or categories of different attack types. So we have MAC table attacks. This includes MAC address flooding attacks. We have VLAN attacks, which includes VLAN hopping and VLAN double tagging attacks. It also includes attacks between devices on a common VLAN. DHCP attacks, which includes DHCP starvation and DHCP spoofing attacks. We see ARP attacks, which includes ARP spoofing and ARP poisoning attacks. We have address spoofing attacks, which includes MAC address and IP address spoofing attacks. And we have SDP, spanning tree protocol attacks, including spanning tree protocol manipulation attacks. Switch attack mitigation techniques. We have some solutions that we can apply to our switches to mitigate for some of these attacks. First solution, port security. This prevents many types of attacks, including MAC address flooding attacks and DHCP starvation. DHCP snooping. This prevents DHCP starvation and DHCP spoofing attacks. We have dynamic ARP inspection, DAI, which prevents ARP spoofing and ARP poisoning attacks. And we have IP source guard, which prevents MAC and IP address spoofing attacks. These layer 2 solutions will not be effective if the management protocols are not secured. The following strategies are recommended. Always use secure variants of management protocols such as SSH, Secure Copy Protocol, SCP, Secure FTP, SFTP, and Secure Socket Layer or Transport Layer Security, SSL or TLS. Consider out-of-the-band management network to manage devices. Use a dedicated management VLAN where nothing but management traffic resides. Use access control lists, ACLs, to filter unwanted access. MAC address table attack. Switch operation review. Recall that to make forwarding decisions, a Layer 2 LAN switch builds a table based on the source MAC addresses in received frames. This is called a MAC address table. MAC address tables are stored in memory and are used to more efficiently switch frames. Here we see an example of a MAC address table. MAC address table flooding. All MAC tables have a fixed size and consequently a switch can run out of resources in which to store MAC addresses. MAC address flooding attacks take advantage of this limitation by bombarding the switch with fake source MAC addresses until the switch MAC address table is full. When this occurs, the switch treats the frame as an unknown unicast and begins to flood all incoming traffic out all ports on the same VLAN without referencing the MAC table. This condition now allows a threat actor to capture all of the frames sent from one host to another on the local LAN or local VLAN. Note, traffic is flooded only within the real local LAN or VLAN. The threat actor can only capture traffic within the local LAN or VLAN to which the threat actor is actually connected. MAC address table attack mitigation. What makes tools such as MACOff so dangerous is that an attacker can create a MAC table overflow attack very quickly. For instance, a Catalyst 6500 switch can store 132,000 MAC addresses in its MAC address table. A tool such as MACOff can flood a switch with up to 8,000 bogus frames per second, creating a MAC address table overflow attack in a matter of a few seconds. Another reason why these attack tools are dangerous is because they are not only affect the local switch, they can also affect other connected Layer 2 switches. When the MAC address table of a switch is full, it starts flooding out all ports, including those connected to other Layer 2 switches. To mitigate MAC address table overflow attacks, network administrators must implement port security. Port security will only allow a specified number of source MAC addresses to be learned on the port. Port security is further discussed in another module. LAN attacks. VLAN hopping attacks. A VLAN hopping attack enables from one VLAN to be seen by another VLAN without the aid of a router. In a basic VLAN hopping attack, the threat actor configures a host to act like a switch to take advantage of the automatic trunking port feature enabled by default on most switch ports. The threat actor configures the host to spoof 802.1q signaling and Cisco proprietary dynamic trunking protocol, DTP, signaling to trunk with the connecting switch. If successful, the switch establishes a trunk link with the host as shown in this figure. Now, the threat actor can access all the VLANs on the switch. The threat actor can send and receive traffic on any VLAN, effectively hopping between VLANs. VLAN double tacking attacks. A threat actor in specific situations could embed a hidden 802.1q tag inside the frame that already has an 802.1q tag. This attack allows the frame to go to a VLAN that the original 802.1q tag did not specify. Step 1. The threat actor sends a double-tagged 802.1q frame to the switch. The outer header has the VLAN tag of the threat actor, which is the same as the native VLAN of the trunk port. Step 2. The frame arrives on the first switch, which looks at the first 4 bytes 802.1q tag. The switch sees that the frame is destined for the native VLAN. The switch forwards the packet out of all native VLAN ports after stripping the VLAN tag. The frame is not retagged because it is part of the native VLAN. At this point, the inner VLAN tag is still intact and has not been inspected by the first switch. Step 3. The frame arrives at the second switch, which has no knowledge that it was supposed to be for the native VLAN. Native VLAN traffic is not tagged by the sending switch as specified in the 802.1q specification. The second switch looks only at the inner 802.1q tag that the threat actor inserted and sees that the frame is destined for the target VLAN. The second switch sends the frame onto the target or floods it, depending on whether there is an existing MAC address table entry for the target. A VLAN double tacking attack is unidirectional and works only when the attacker is connected to a port residing in the same VLAN as the native VLAN of the trunk port. The idea is that double tagging allows the attacker to send data to hosts or servers on the VLAN that otherwise would be blocked by some type of access control configuration. Presumably, the return traffic will also be permitted, thus giving the attacker the ability to communicate with devices on the normally blocked VLAN. VLAN attack mitigation. VLAN hopping and VLAN double tagging attacks can be prevented by implementing the following trunk security guidelines as discussed in the next module. Disable trunking on all access ports. Disable auto trunking on trunk links so that trunks must be manually enabled. Be sure that native VLAN is only used for trunk links. DHCP messages. DHCP servers dynamically provide IP configuration information, including IP address, subnet mask, default gateway, DNS services, and more to clients. A review of the sequence of the DHCP message exchange between client and server is shown in this figure. So we have DHCP discover, DHCP offer, DHCP request, and DHCP acknowledgement. DHCP attacks. Two types of DHCP attacks are DHCP starvation and DHCP spoofing. Both attacks are mitigated by implementing DHCP snooping. DHCP starvation attack. The goal of this attack is to create a DOS for connecting, a denial of service for connecting clients. DHCP starvation attacks require an attack tool such as Gobbler. Gobbler has the ability to look at the entire scope of leasable IP addresses and tries to lease them all. Specifically, it creates DHCP discovery messages with bogus MAC addresses. DHCP spoofing attack. This occurs when a rogue DHCP server is connected to the network and provides false IP configuration parameters to legitimate clients. A rogue server can provide a variety of misleading information, including the following. Wrong default gateway. The rogue server provides an invalid gateway or the IP address of its host to create a man-in-the-middle attack. This may go entirely undetected as the intruder intercepts the data flow through the network. Wrong DNS server. The rogue server provides an incorrect DNS server address pointing the user to a nefarious website. Wrong IP address. The rogue server provides an invalid IP address, effectively creating a DOS attack on the client, DHCP client. ARP attacks. Hosts broadcast ARP requests to determine the MAC address of a host with a destination IP address. All hosts on the subnet receive and process the ARP request. The host with the matching IP address in the ARP request sends an ARP reply. A client can send an unsolicited ARP reply called an gratuitous ARP. Other hosts on the subnet store the MAC address and IP address contained in the gratuitous ARP in their ARP tables. An attacker can send a gratuitous ARP message containing a spoofed MAC address to a switch, and the switch would update its MAC table accordingly. In a typical attack, a threat actor sends unsolicited ARP replies to other hosts on the subnet with the MAC address of the threat actor and the IP address of the default gateway, effectively setting up a man-in-the-middle attack. There are many tools available on the internet to create ARP man-in-the-middle attacks. IPv6 uses IPv6 Neighbor Discovery Protocol for Layer 2 address resolution. IPv6 includes strategies to mitigate neighbor advertisement spoofing, similar to the way IPv6 prevents a spoofed ARP reply. ARP spoofing and ARP poisoning are mitigated by implementing dynamic ARP inspection, DAI. Address spoofing attacks. IP address spoofing is when a threat actor hijacks a valid IP address or of another device on the subnet or uses a random IP address. IP address spoofing is difficult to mitigate, especially when it is used inside a subnet in which the IP belongs. MAC address spoofing attacks occur when the threat actors alter the MAC address of their host to match other known MAC address of the target host. The switch overwrites the current MAC table entry and assigns the MAC address to the new port. It then inadvertently forwards frames destined for the target host to the attacking host. When the target host sends traffic, the switch will correct the error, realigning the MAC address to the original port. To stop the switch from returning the port assignment to its correct state, the threat actor can create a program or script that will constantly send frames to the switch so that the switch maintains the incorrect or spoofed information. There is no security mechanism at Layer 2 that allows the switch to verify the source of MAC addresses, which is what makes it so vulnerable to spoofing. IP and MAC address spoofing can be mitigated by implementing IP source guard. Spanning tree protocol attack. Network attackers can manipulate the spanning tree protocol to conduct an attack by spoofing the root bridge and changing the topology of a network. Attackers can then capture all traffic for the immediate switch domain. To conduct a SDP manipulation attack, the attacking host broadcasts spanning tree protocol bridge protocol data units, BPDUs, containing configuration and topology changes that will force spanning tree recalculation. The BPDUs sent by the attacking host announce a lower bridge priority in an attempt to be elected as the root bridge. This spanning tree protocol attack is mitigated by implementing BPDU guard on all access ports. BPDU guard is discussed in more detail later in the module. CDP reconnaissance. The Cisco Discovery Protocol, CDP, is a proprietary Layer 2 link discovery protocol. It is enabled on all Cisco devices by default. Network administrators also use CDP to help configure and troubleshoot network devices. CDP information is sent out CDP-enabled ports in periodic, unencrypted, unauthenticated broadcasts. CDP information includes the IP address of the device, the iOS software version, platform capabilities, and the native VLAN. The device receiving the CDP message updates its CDP database. To mitigate the exploitation of CDP, limit the use of CDP on devices or ports. For example, disable CDP on edge ports that connect to untrusted devices. To disable CDP globally on a device, use the no CDP run in the global configuration mode. To enable CDP globally, use the CDP run in the global configuration mode. To disable CDP on a port, use no CDP enable interface configuration command. To enable CDP on a port, use the CDP enable interface configuration command. Note, Link Layer Discovery Protocol, LLDP, is also vulnerable to reconnaissance attacks. Configure no LLDP run to disable LLDP globally. To disable LLDP on an interface, configure no LLDP transmit and no LLDP receive. So what have we learned this week? So endpoints are particularly susceptible to malware-related attacks that originate through email or web browsing, such as DDoS, data breaches, and malware. These endpoints have typically used traditional host-based security features such as antivirus and anti-malware, host-based firewalls, and host-based intrusion prevention systems. Endpoints are best protected by a combination of NAC, host-based AMP software, an email security appliance, and a web security appliance. AAA controls who is permitted to access a network, authenticate, what they can do while they are there, authorize, and to audit what actions they performed while accessing the network, accounting. The IEEE 802.1x standard is a port-based access control and authentication protocol that restricts unauthorized workstations from connecting to a LAN through publicly accessible switch ports. If layer 2 is compromised, then all layers above it are also affected. The first step in mitigating attacks on a layer 2 infrastructure is to understand the underlying operation of layer 2 and the layer 2 solutions: port security, DHCP snooping, DAI, and IPSG. These won't work unless management protocols are also secured. MAC address flooding attacks bombard the switch with fake source MAC addresses until the switch MAC address table is full. A VLAN hopping attack enables traffic from one VLAN to be seen by another VLAN without the aid of a router. A VLAN double tagging attack is unidirectional and works only when the threat actor is connected to a port residing in the same VLAN as the native VLAN of the trunk port. VLAN hopping and VLAN double tagging attacks can be prevented by implementing the following trunk security guidelines: disable trunking on all access ports, disable auto trunking on trunk links that the trunks must be manually enabled, be sure that the native VLAN is only used for trunk links. Two types of DHCP attacks are DHCP starvation and DHCP spoofing. Both attacks are mitigated by implementing DHCP snooping. ARP attack: a threat actor sends a gratuitous ARP message containing a spoofed MAC address to a switch. The switch updates its MAC table accordingly. Now the threat actor sends unsolicited ARP replies to other hosts on the subnet with the MAC address of the threat actor and IP address of the default gateway. ARP spoofing and ARP poisoning are mitigated by implementing DAI. Address spoofing attack: IP address spoofing is when a threat actor hijacks a valid IP address of another device on the subnet or uses a random IP address. MAC address spoofing attacks occur when the threat actors alter the MAC address of their host to match another known MAC address of a target host. IP and MAC address spoofing can be mitigated by implementing IPGSG. Spanning tree protocol attack: threat actors manipulate spanning tree protocol to conduct an attack by spoofing the root bridge and changing the topology of the network. Threat actors make their hosts appear as root bridges, therefore capturing all traffic for the immediate switch domain. This spanning tree protocol attack is mitigated by implementing BDPU guard on all access ports. CDP reconnaissance: CDP information is sent out CDP-enabled ports in periodic unencrypted broadcasts. CDP information includes the IP address of the device, iOS version, platform capabilities, and native VLAN. The device receiving the CDP message updates its CDP database. The information provided by CDP can also be used by a threat actor to discover network infrastructure vulnerabilities. To mitigate the exploitation of CDP, limit the use of CDP on devices or ports.